Everyone, welcome to my channel. If you are new here, my name is Veronica, known as Data Geek is my name. Please, if you haven't already, subscribe to my channel, like the video, share the video, and even comment. I love hearing from you guys. And today, we're cleaning messy geospatial data in Python to turn broken coordinates and inconsistent county codes into a clean data set for you to trust for mapping and analysis. We'll fix messy latitude, longitude, and detect swapping coordinates, standardize county info, normalize dates and metrics, and end with a quick map preview. But first, if you don't know already, what is geospatial? It is information tied to a specific location on Earth, such as like city, names, addresses, coordinates, which is latitude and longitude, or regions on a map. And why is this so important? Well, we find and visualize where things actually happen. We build patterns and relationships. We can build maps that drive better decisions from business insights, public health, and city planning. So let's jump into Jupyter Notebook, where I'm going to show you how to do a step-by-step tutorial on how to gather this information. So here I am in my Jupyter Notebook. So first off, I just want to mention that I use Anaconda Navigator to launch Jupyter Notebook. So if you haven't already downloaded Jupyter Notebook, I will link a video in the description below that I created to show you how to download Anaconda Navigator, which has many free tools for you to utilize when working with data analytics. Also in the description below, I will put a link to the dataset that we will be using today so you can follow along. So first, let's take a look at our dataset. So here are my two data sets I'm going to be using. So I have them in my folder. First one is county lookup. So this is the first data set I'm going to be using to do a county lookup. So you can see it has a county name, which is United States, United Kingdom, and then these here for US or USA for United States. So then our other data set we're going to be using is our geospatial. So this is the dirty data set and the location. So I'm going to open this up. All right, so this is it here. So we have the record ID, we have city, county, and we have these columns here that are going to do our lookup on. We have our region number, postal code, latitude, longitude, report date, metric raw, and CRS hint. So you can see there's a lot of missing stuff here. There's some that are dates and some that are decimal numbers. We're going to clean this up. Again, it's messy data on purpose so we can clean it all up. So going back to Jupyter Notebook, I'm going to show you how to upload this in there. All right, so now I'm going to go ahead and show you how to upload those two files into your Jupyter Notebook. So again, you can do it from Jupyter Notebook, and if not, you could also do it in your file location. You just need to put down the file path when you're pulling in that data into your Python code. So right now what we're going to do is click on this upload button here, the top right. Then you select your file location and then click on both of those files and open. Now you see them here at the bottom. So now they're inside your Jupyter Notebook. Now we'll go ahead and start our Python code. So we'll go ahead and click up here, New, Python. Close this out. I'm going to zoom in a bit. So now we have our first cell. It's blank, and now we're going to start our code. So first I'm going to put this one as a markdown. I'm going to put a number side there. The more number sides you make, the more of your text will go smaller. It's just a caption. So this is going to be step 1. We're going to import and set up. And now I'm going to add another cell. Now if Folium isn't installed, you need to run this one time. And you will do is do exclamation pip install Folium. Then you will hit the run button. In this case, I've already installed this. So once you are done installing, we'll add another cell. I'm pressing warnings to keep the output clean on the screen. Importing the libraries we'll use Pandas and NumPy for cleaning, and Folium for an interactive map. If you see an error that Folium isn't installed, just run pip install Folium in a cell and rerun this section. And we will run this code. And it gave us a number, so it ran successfully. Again, I'm going to put this as a markdown, and then I will put the number sign, and this will be step 2, where we will load the files. Now we'll run this. I'm loading 2 files, a messy geospatial dataset and a clean county lookup table. So these files live in the same folder as my notebook, as I showed you how to upload these in Jupyter Notebook. So once loaded, I'll quickly preview the shape and the first few rows to confirm everything looks right. All right, and I ran the code and it ran successfully. So here's a peek at the first 3 rows from our messy dataset. So each row represents a location report. So let's break down these columns. So as you can see, record ID, which is that first column, it's a unique ID for each record. Then there's city and county. So these are text fields that may be inconsistent, such as like misspelling. Then there's the ISO2, ISO3. These are county codes, but not always accurate. Then there's region and postal code, extra location context. Then there's latitude and longitude, the date of the report, but you can see they are in mixed formats. And then there's the matrix raw, stored as text. Notice the commas and the dots. And then the CRS hint. So the coordinate system hint, like ESG. So this is why cleaning is so important. So obviously there are format issues, inconsistent county data, and possibly swapping or broken coordinates. All right, so we are in step 3. So I will change this to markdown. And again, step 3, we are going to do a quick audit and add a cell. So before cleaning, let's get a quick health check. How many rows do we have? How many exact duplicates? And how many missing coordinates? I'll also show summary stats for numeric columns. So we have a baseline. This will give us a to-do list for our cleaning steps. All right, so here's a quick health check of our data set. So the summary of issues, we have 530 rows, which is here. We have 6 exact duplicates. We have 42 missing latitudes. And we have 0, which is no missing longitudes. So just to let you know that duplicates can inflate counts, and missing latitudes will break our map until we fix them. Now below here, it shows a numeric summary for a few columns. So record ID looks good. It's 530 value, increasing around the 10,000s. So the postal code is numeric number, but however, remember, postal codes are identifiers, not quantities. So we won't do math on them. And then latitude has 488 valid values out of the 530, which matches the 42 missing we saw earlier. And then the longitude has 530 valid values, so no gaps there. So let's look at the ranges to spot potential problems. So if we look at latitude, it should be between -90 and +90. Our min, which is here in the middle, it shows -118.24, and the max is 187.11. So that's impossible for real world coordinates. So this is a big clue we've got swapped latitude and longitude values or out of range errors to clean. So the longitude should be between -80 and +80. And ours runs from 123, the min, and the max is 151. So that's valid. So now we know we have some cleaning to do. So now let's go ahead and go to step number 4. Drop exact duplicates. I'm going to change this up here from code to a markdown and run this. So next I'm removing exact duplicate rows. So duplicates can inflate counts, distort maps, and slow things down. So this is an easy, safe win at the start. All right, and then I run this code. Now very simple output, it says dropped 0 duplicate rows, and current rows are 524. All right, now going to step number 5. We're going to do a standardize county, an ISO/name, Canonical, and change this from code to markdown and run that. All right, so this is a very long code. So what I did is I just have it already typed up. So I'm going to just do a copy and paste. I'll go through each step. So this first part is we're going to build lowercase name to match text and counties. So we do a lookup underscore name equals lookup dot assign. And then we do the county lowercase, and then we do the lookup county name, and we do a string for lowercase. The next part of the code is a DEF, normalized underscore county value, an NA value, so return pd.series. So we're going to do a county name clean, np.nan, and ISO2 underscore clean. So the red parts are our output. Then v equals string value, string. What we have here is our ISO2. And I will go ahead and put the rest in here. So save time on this video. So if you're not sure what ISO2 is, so it's a 2-letter code for each county. So for example, when we saw in the data set, it had United States, and then the 2-letter code is US for United States, and then the ISO3 is an alpha 3 code. So that's a 3-letter code for each county. So for example, United States would be USA, which is the 3 letters. So that's what these are representing here. And it looks those up. So then also the name, so lowercase, and then the no match, which will return this, pd.series, and then county norm. Then we call all of these here, and we do the .head, which is reviewing the top 10 rows of the data. So I'll go ahead and run this. Here I normalized all county values into 3 columns. A canonical name, ISO2, ISO3. So this makes joins and mapping consistent no matter how the original value was written. So then now going to step number 6, I'm going to change this to markdown. Here we're going to clean city text, add another cell. City names often have extra spaces or numeric lookalikes, like the number 0 used instead of the letter O. I'm trimming white spaces, fixing common lookalikes, and standardizing the text so cities can match cleanly across sources. All right, so now we want to see the head of the first 10 rows. So I'm going to go ahead and run this. So as you can see on the left, you see the original city values from the data set, and the right is our new city cleaned column. At a first glance, they look almost the same, and that's good. It means these examples didn't need much fixing. But behind the scenes, the cleaning function is removing extra spaces, fixing any numeric characters like zeros that might have been accidentally used instead of the letter O, and making sure the text is consistently formatted. And this step ensures every city is standardized so they can be grouped correctly in analysis and on the map. Step 7. So we're going to fix coordinates, so swap detection out of range like NANs. So coordinates are the heart of the geospectrum work, so we validate them carefully. If latitude and longitude look swapped, we flip them back. Anything truly out of range gets set to missing, so it won't populate our map. This step prevents points from landing in the ocean or any other continent. Alright, so I'm going to go ahead and paste in this code because it is a long code. Again, I want to save some time for this video. So this first part here, I'm starting by creating a helper function called is_valid latitude. It checks if a value can be converted to a number and is between -90 and +90, which is the valid range for latitude. So this will help catch any bad or swapped values. Next, I'm creating a similar helper function called is_valid_LON, which is for longitude. So it makes sure the value is a number between -180 and +180, which is the valid range for longitude. And then now here, I'm detecting and swapping mistaken coordinates. So now I'm looping through every row in the dataset and checking for swapped coordinates. So if the latitude looks invalid, but the longitude is valid as a latitude, and vice versa, I swap them back. This fixes any rows where if somebody accidentally flipped the values. And I'm also counting how many swaps we make. So in this section, after fixing the swaps, I'm checking again for anything still out of range. Any value outside the valid latitude or longitude range gets set to NaN. This removes impossible points so they don't end up floating somewhere in the ocean or on our map. And finally, I run the .described. I'll go ahead and run this code. And it ran successfully. So again, we have our latitude and longitude. Now going to step number 8, I'm going to change this to Markdown to step 8. And now we're going to normalize dates. So basically our dates came in mixed formats. So I standardized everything into a single date time column. If a value is invalid, it becomes null instead of crashing the notebook. So consistent dates make filtering and time-based analysis reliable. .head. We want to see 8 rows of the head of our data. So we'll go ahead and run this. So here we can see the results of our data cleaning steps. So on the left, we have the original report date. These are the original values. And on the right, the new report date column that we created with pd.to_datetime. So notice how some dates were successfully converted into a standard like year, 4-digit year, 2-digit month, 2-digit day format. Like for example, January 8th, 2025. And then here it has like the dots separating what's the original date format here, right? But some rows shows NAT, which stands for not a time. So that means the date couldn't be shown. So this is normal when dealing with messy real-world data. It helps us quickly spot which rows need fixing or dropping before analysis. So now going to step number 9. So I'm going to go ahead and paste this in again to save time for this video. Now in this step, we're going to clean the matrix raw column. Right now, these values are stored as text and they use different number formats. Some use commas as thousand separator and others use commas as decimal points. So this column function called Parse_matrix goes through each value, fixes the formatting, and then turns it into a real number, which is a float. This way Python can understand it better. So I'll go ahead and run this code. So now if the value is blank, it will give us an NaN, which says right here. If it has both a comma and a dot, it removes the commas, and then that way it makes their thousand separator. If it only has a comma, it replaces them with dots so they act as a decimal point. Then they try to convert it to a float number. So here is our first 8 rows. and everything looks good. Now going to step number 10. So this code is very lengthy. So here I'm preparing the clean data for mapping. In this section here, I first remove any rows missing latitude and longitude and add extra guardrails to make sure all coordinates are valid, which latitude must be between -90 and +90, and longitude between -180 and +180. That's what I do here. Next, then I calculate the center of all the points and use it to center the map. This way the map automatically focuses on where the data is. Then I'm using the Folium .map to build the map starting with the clean base layer. And then next I loop through each point and create a marker cluster. This keeps the map from getting cluttered. When points are close together, they group into clusters until you zoom in. I'm also adding a heat map layer, which uses the metric column to highlight hotspots. Brighter areas show higher intensity, helping you spot patterns quickly. Finally, I add a layer control in the top right corner so you can switch between the clusters and the heat map. And let's run this. And ta-da, here we go. Here is our heat map. Now let's explore the interactive map we just created. So each circle marker represents one record from our clean data set. The markers are grouped into clusters, so you'll see them in circles with numbers inside. So the green clusters means there are only a few points grouped together. As you zoom in and the points spread out, the clusters' colors change based on the number of points inside them. So now that you have an interactive map, now you want to save the data set that you cleaned. You can share the results or save it for later for more analysis. So I'm going to export the clean CSV and save the interactive map as an HTML file. So you can open the map in any browser, email it to your team, or host it on a site. So no extra tools needed. And that will be this code here. So out_CSV, data_direct. And this is our CSV name. So if I run this code, it says it was saved. And it went to my C file. Now you are all ready to share your files. And that is it. And that is it. We turned a messy data set into a clean one. And we mapped it all out. And now you can go ahead and share it. If you found this helpful, hit that like button, subscribe for more Python and analytic tutorials, and drop a comment with the next dataset you want me to clean. Thank you again for watching, and I will see you on the next one.